Good morning, everyone. Today we're looking at Unit 4, Lesson 2, Properties of Quadratic Relations. So in the previous day, we learned what a quadratic relation was, and we also talked about how we can identify a quadratic relation. So we talked about their second differences are constant, the degree of the equation is a degree of 2, and it's also the shape of a parabola. So there's a parabolic curve when you graph it. So today we are going to continue looking at our quadratics, especially their graphs, and identify some of the key points on them. All right, so we'll get started with this quadratic relation, y equals x squared plus 2x plus 3. We're going to create a table of values. So just to remember how we use our table of values, I'll substitute in this first value. So my y value is going to equal, I'm going to sub in a -3 anywhere I see x. Okay, and you'll have to solve for that. So -3 squared is 9. 2 times -3 is a -6 plus 3. Okay, 9 minus 6 is 3. 3 plus 3 is 6. So that's what goes in the box. Okay, if you did that for each of those values in the table of values, substituting in whatever x is, your next y value when you substitute in a -2 is going to be 3. Then you'd have 2, 3, 6. So we're going to graph this relation. We're going to be at -3, positive 6. Then we're going to be at -2 and 3. We'll be at -1 and 2. And then 0 and 3 and 1 and 6. So we will connect those dots to make a smooth curve that we call a parabola. All right, so what is our y-intercept? Again, we can identify our y-intercept. This is not new information, it's just a different looking kind of graph. Where does the parabola cross our y-axis? So our y-intercept is going to be at a positive 3. Are there any x-intercepts? If so, what are the values? So does it cross the x-axis? The answer would be no, right? Our parabola does not. So no, it doesn't cross. So no x-intercepts in this case. What is the coordinate of the lowest point on the curve? So the lowest point on the curve we can see is right here because every other point is above that. So the coordinate, we would say that is a minimum. And that minimum occurs at over 1, so -1, and then up 2. So at -1 and 2. Okay, so we're going to start talking about some of the key vocabulary. So we can look and say, what's my lowest point? What's my y-intercept? That's all terminology we can deal with. But parabolas have very specific vocabulary that we need to start becoming familiar with. So the first one is the vertex. Okay, so the vertex is the turning point. Okay, it's going to be the turning point of the curve, and it's going to be a maximum or a minimum point on the parabola. So when we just asked what's the lowest point, we said it was a minimum, right? That is my vertex. That is where the graph starts to turn. And what I mean by turn is you can see as if I look at my curve from left to right, the curve is going down, down, down. And then when I get to that vertex, when I get to that minimum, this turning point, the graph switches direction and it starts to go up. So it goes from a decreasing curve to increasing. So that's what we mean by turning point. You're going to have a maximum if the y-coordinate of the vertex is the largest y value of the parabola. And you're going to have, let's highlight that. It's going to be a maximum if the y-coordinate of the vertex is the largest y value on the parabola. You're going to have a minimum if the y-coordinate of the vertex is the smallest y value of the parabola. So you're not going to have both. You have to identify, do I have a maximum or do I have a minimum? Okay, in this case, our graph is showing that we have a minimum. Some other key vocabulary. The optimum value. Okay, the optimum value is simply the y value of your vertex. Okay, so it's the y coordinate of your vertex. So it's going to be what is your max or min. Okay, if we were looking at it in this case, the optimum value of this example here, so from our example, our optimum value is going to be at 2, right? So it's the y value of my vertex. My vertex is at -1, 2. So let's just identify that. That's our vertex. It's at -1, +2, and this part is our optimum value. Okay. Parabolas are symmetrical about a vertical line drawn through the vertex. So if I was to draw a vertical line, and we always draw it with dots, not to confuse it as being part of the parabola. Okay, this vertical line is known as the axis of symmetry. The axis of symmetry is the x value of the vertex. So if you had a vertex at 2, -3, the equation of the axis of symmetry is at x equals 2. So let's just, the key point here is that the axis of symmetry is the x value of your vertex. So if we come back up to our equation, our axis of symmetry is going to be at x equals whatever the x value of my vertex is. The x value of my vertex is at -1, right? So we're at x equals -1 for our axis of symmetry. The last kind of key vocabulary we're going to talk about is our zeros. So our zeros are points where the parabola crosses the x-axis. These are also known as our x-intercepts. So it's where does the graph actually cross the x-axis? So we sometimes call those our x-intercepts. But when we're talking about them with parabolas, we'll call them our zeros. So we're going to look at a couple of examples now and see if we can identify some of these new key vocabulary for quadratics. So on the graph to the right, what is the coordinate of the vertex? So remember, our vertex is our turning point. So our vertex is going to be right here. Okay, so this is our vertex. 1, 4. So we'll write that on the line. So our vertex is at 1, 4. And we labeled the vertex. Does this graph have a maximum or a minimum? Well, again, it goes on forever in this direction. So we would say that there's a maximum. There's a maximum point. And what is that optimum value? Remember, our optimum value is simply the y value of our vertex. So our optimum value is going to be at y equals, we're going to write maximum here. Wrote it on the wrong line. And our optimum value is going to be at y equals 4. Okay, what is the equation of our axis of symmetry? Well, our axis of symmetry is just the vertical line that cuts that parabola in half, and it is the x value of your vertex. So it's going to be x equals 1. And we're going to label our axis of symmetry. So this is our axis, and it is at x equals 1. What are the values of our zeros? So our zeros are where does it cross the x-axis? So we have zeros at, our first zero is here at -1, and we have another one at +3. Okay, we're going to label our zeros. So let's just draw some arrows to it. We could always refer back to our notes if we're unsure what some of these key points are. So zeros are at -1 and +3. All right, we'll look at a few more examples. Our vertex in question 1. So we did label it. And if we look here, is that a minimum or a maximum? Right? Well, it's the lowest point. It's not the highest point. So go back and have a look at example 1. Remember, in example 1, okay, the graph did not cross the x-axis. So we didn't. Okay, so without graphing the data in the following tables of values, determine if the data represents a quadratic relation, and we're going to decide whether it opens up or down. So we're going to go back to looking at our first and second differences. We will try one together, and then I'll get you guys to try one on your own. So remember, we have our first, and then we're going to do our second, if our first differences are not the same. Okay, so our first differences, looks like 4 to -2, we are going down by 6. And then -2 to -4, we're going down by 2 again. Okay, and then we switch directions. We go from -4 to -2 means I'm going up by 2. And then finally from -2 to +4, we're going up by 6. So my first differences aren't constant. We'll take a look at our second differences. So those are just comparing our first differences. So as we go from -6 to -2, we are increasing by 4. And then we go from -2 to +2. Again, that's an increase of 4. And finally, we go from +2 to +6, another increase of 4. So now we can see our second differences are constant, which tells us it is a quadratic. So therefore, we have a quadratic, and it's going to point up, okay? And we can say in here, because our second difference is constant at +4, right? So our second difference is constant, which tells us it's quadratic, and it tells us it points up because it's at +4. Okay, pause the video and see if you can work through that second table of values, determining if it's quadratic or not based on its finite differences, and if it's going to point up or if it's going to point down. So if you calculated your first and your second differences, hopefully you would see that your second differences are constant at a -2, which tells us that this relation is also a quadratic, and because our second difference is negative, it's going to point down. Okay, so moving right along here, we will continue working with these kind of key points and key vocabulary that we've been discussing. So it says, using the pair of points located on opposite sides of the same parabola, determine the equation of the axis of symmetry of the parabola. So if we were to plot these points, for example, let's say that we had a -4, 5, and we had 8, 5. So if I had a -4, 5, that may be right there. And I'll just put -4, 5. And then if we had something at 8, 5, maybe somewhere over here. Okay, it says these are points that are located on opposite sides of the same parabola. Determine the equation of the axis of symmetry. So remember, the axis of symmetry, it's going to split our parabola in half. Vertically. Okay, so if I was to draw this parabola, we're just kind of taking a guess where it's going to fall, but we do know that it's on opposite sides. So if we wanted to say the middle of the parabola somewhere maybe here, right, somewhere in here maybe would be the middle, then that would represent essentially where the turning point was, because these 2 points are on opposite sides of the parabola, meaning they're kind of equal distance away. So our axis of symmetry is going to fall somewhere in between, right in the middle of those points. So we can say here that since it splits the parabola in half vertically, it will be midway between the given points. Okay, so if we're looking at how do we find between 2 points, we should be thinking like our midpoint, like we did in our analytic geometry. So we would have to think essentially what is the middle, and since our axis of symmetry only ever deals with our x values, we're only going to look at the middle of our x values. So the middle of our x values is going to be taking our x from one coordinate and our x from our other coordinate, adding them together, and divide by 2. So the midpoint of our x's is going to be at -4 plus 8 is 4, divided by 2 is 2. Okay, so our axis of symmetry, we could say, would be x equals 2. Okay, let's take a look at another example. So we're trying to look at the midway point between 6, -2 and 11, -2. We're again going to take the midpoint of our x's. So we're going to have 6 plus 11 divided by 2, which equals 17 over 2, or we can say 8.5. Okay, so both of these, okay, Both of these are going to represent the equation for axis of symmetry. If we did a rough sketch of our second example here, all right, if we just did a rough sketch, we have one point that is at 6, -2. So let's say 6, -2 is, oh, that -2 is down too far. Let's say 6, -2, and then let's say we were at 11, -2, right? We don't know if it's pointing up or down, which is fine, but we do know that the axis of symmetry is going to be in the middle. So if I was trying to draw, oh, that doesn't look overly in the middle. If I was trying to draw it, we should show that the middle is going to be somewhere in between those 2 points. So we would say our axis of symmetry would go somewhere there, x equals 8.5. Okay. Continuing on, continuing to look at some of this vocabulary, determine if the vertex represents a maximum or a minimum. So is it a maximum or a minimum? When you're given information like this, I always think a rough sketch kind of helps us visualize what is going on. So it says we have zeros. Let's graph it over here. We have zeros, which remember our zeros are just our x-intercepts. Right? We have zeros at -7. So we'll say an x-intercept here at -7. So we can say -7 and 0. And then we have another 0 or x-intercept at 3. So maybe like right there. Then it says we have a vertex at -2, -5. Okay, so let's say that's -2, -5. Well, if we wanted to connect these dots, right, knowing that we're dealing with quadratic relations here, we can see what shape this parabola is going to have or which way it's going to point. So we can see it's pointing up, right? So if it's pointing up, then we can say that this is going to be a minimum. So therefore, the vertex is a minimum. And let's just label that again. So this is not only my minimum, but this is also my vertex on this drawing, right? That vertex is that turning point. Okay, so if we go back to that initial question that we started with, it says for question 1, which I think we did kind of a lot of this along the way, but for question 1, label the vertex. Does it represent a maximum or a minimum? So let's go back and have a look. So it's going to be a minimum. So let's say that we have a minimum at, and our vertex was -1, -2. What is the optimum value? Let's remember our optimum value is the y coordinate from our vertex. Okay, so our optimum value is going to be at y equals -2. Okay, our axis of symmetry is going to be the x from our vertex. So x coordinate from our vertex. So if our minimum was at -1, -2, our axis of symmetry is going to be at that -1. That's the x from it. And then the last part says state and label the zeros if they exist. Any x-intercepts, we didn't have any zeros, so we'll just say no zeros exist. That is all for your note for today.